All right, here's a little more help with price elasticity of demand or calculating price elasticity of demand. We'll work through a few sample problems and can help you with your assignment problems that are due on Friday. So first question says a rise in the price of a certain commodity from $15 to $20. And the commodity is any good that is going to be identical or uniform in its sales. So a bushel of corn, a bushel of wheat, a ton of steel, a barrel of crude oil, right? That we call those things commodities. So any commodity that's going from $15 to $20 is going to reduce the quantity demanded of that from 20,000 to 5,000 units. And we need to calculate the price elasticity using that midpoint formula. Again, that's going to allow us to see the same elasticity value, whether we're going from, or the same responsiveness value, whether we're going from 15 up to 20 or from 20 down to 15. Right? We're taking the average of that. So if we remember our midpoint formula, right, it's the change in quantity divided by quantity 1 plus quantity 2 divided by 2. That gives us the average. And then we're going to divide that value by the change in price all over price 1 plus price 2 divided by 2. So that's our formula that we use for price elasticity of demand. And here's our values. We're looking at a price change going from $15 to $20. In a quantity, and this is again in thousands, I'm just simplifying it for the math piece, we're going from 20 down to 5. So an increase from $15 to 20, we see a decrease from 20 down to 5, and our job is to calculate the price elasticity of demand. So if we plug our values in here, our change in quantity, right, we're going from we're going from 20 down to 5, that's at minus 15. Okay, and then we're going to take quantity 1, which is 20, and quantity 2, which is 5, add them together, okay, and we'll divide that by 2. Our price, we'll fill that in. Our price change is 5. See, we're going from 15 to 20. It's 5. And we take price 1, 15, price 2 is 20, add those together, and we divide that value by 2. So just kind of working our way down here. If I take 20 and 5, it gives me 25, and I divide that value by 2, I get 12.5. If I take 15 and add it to 20, I get 35, divide that by 2, and it gives me 17.5. So now I've got the numbers that I can work with here. So if I take my percentage change, and that's what I'm figuring out here in quantity, I take negative 15, divide that by 12.5, it gives me negative 1.2. So this quantity change is 120% decrease in quantity is really what we're looking at here. And we're going to divide that by a percentage change in price. So if I take 5 divided by 17.5, it gives me 0.29. So a 29% change in price, and we have a 120% or a negative 120% change in quantity. If I divide my percentage change in quantity by my percentage change in price, it gives me a negative 4.13, and we always take absolute value. So our elasticity of demand value is 4.13 for that first problem. Now we know, right, when we're looking at elasticity, if this value is less than 1, which ours is not, but if it's less than 1, we call that inelastic, meaning it's not relatively very responsive to price change. Well, here it's significantly larger. It's 4, so it's much greater than 1, which means it's elastic demand. That price is going to be, or the quantity demand is going to be very sensitive to a price change. So a little price change, right, 29%, 15 up to 20. If a small price change is going to lead to a significant, a very large response in the action of consumers. So we're going to go from 20 all the way down to 5. So that's what elasticity allows us to see. Let's look at our second question. It says if the price falls from 6 to 4, so from $6 to 4, and the quantity demanded rises from 8 to 12,000, calculate the price elasticity of demand using the midpoints. Second part of the question is what would happen to the firm's total revenue? We'll get into total revenue here in another video. that's kind of a very important piece, but we're just going to take baby steps as we go here. So let's kind of work through that one really quick. Price, we're going from 6 down to 4. In quantity, we're going, and I'm going to go in terms of thousands again, so I can simplify 8 up to 12. Okay. So we're going to take and plug these values into our formula. Our change in quantity, we got that up here. Remember our formula up here. Scroll out here. So our change in quantity, okay, change in quantity is going to be 4 all over quantity 1, quantity 2. So 8 plus 12 divided by 2, and divide that by our change in price, 6 to 4, which is a negative 2, all over 6 plus 4 divided by 2. So now we have 4 all over. 8 plus 12 is 20, divided by 2 is 10. Divide that by negative 2 all over. 6 plus 4 is 10, divided by 2 is 5. Okay, so if we take 4 and divide that by 10, it gives us 0.4. And we take negative 2 divided by 5. That gives us a negative 0.4. So we're going to get a negative 0.4 divided by a negative 0.4. Gives us a negative 1. All right, we take absolute value. So our elasticity of demand is equal to 1. So now we've got a new value. It's not greater than 1, not less than 1. It's actually equal to 1. When it's equal to 1, we get what's called unit elastic. So what this means is, right, we're going to see a equal percentage change in the quantity in price. So if a 10% change in 10% increase in price will lead to a 10% decrease in quantity. This spot unit elastic is actually at the midpoint, the exact midpoint of our demand curve, wherever that would be. We'll get more into the linear demand curve and how we break that up. But what we know here is this is unit elastic. And the last one that we'll look at here is number 3. It says if the price elasticity of demand for a commodity is estimated to be 1.8. Okay, so 1.8 is our value of elasticity. We don't have to go and calculate it, it's given to us. So elasticity of demand is equal to 1.8. Then a decrease in price from $2.10 to $1.90 would be expected to increase daily sales. And this is going to say daily sales by what? We know that a price decrease is going to increase quantity demand, but if we go from $2.10 down to $1.90, how much are our sales going to increase? So how do we figure that out? We've got a value of 1.8. Well, let's look at how we would figure that one. So we got an elasticity value of 1.8, and we're looking at a price change of $2.10 down to $1.80, $1.90. So 210 down to $1.90. So we're going to figure out first of all what this percentage change in price is going to be. So we got to figure that average out. Okay, so what's our change? Right, so we're just going to do half of that formula. So we're going to find percentage or change in price, P1 plus P2 divided by 2. We're going to figure what that equals. So our change, we're going from 210 down to 90 cents. That is 20 cents. It's negative. And we're going sorry about that. And we're going price 1 and price 2, so 210 plus 1.9, okay, divided by 2. So we can see that we got $4 here. We add these two up, divide that by 2 is going to give us $2. So we got minus 0.20 all over $2. And if we divide that, divided by 2, okay, it's going to give us negative 0.1 with the absolute value. So our percentage change in price is 0.1. In this case, it's negative. We're going downward, but so we've got a 10% change in price. Okay, 10%. So if we take this value and we have an elasticity value of 1.8, if we take that 0.1 and multiply it by our elasticity value, 1.8, okay, 0.1 times 1.8, it's going to give us a percent. It's going to give us 0.18. So what this tells us, okay, with the elasticity value of 1.8, a 10%, in this case, a 10% decrease in price, okay, going from $2.10 to $1.90, that's a 10% decrease in price. When we multiply that by our elasticity of demand value, we get an 18%. So we see an 18% increase in quantity demanded. 18% increase in quantity demanded. So if the elasticity of demand is 1.8, then a decrease in price from $2.10 to $1.90, which we found out was 10% decrease, we would expect to increase daily sales by, correct answer would be 18%. All right, hope that helps. Good luck.